Welcome to MATHurdays. Math's so fun. We do it on Saturdays. My name is Teresa Wells. I am so excited that you're here. I see some returning folks who've attended several MATHurdays before. I see some new folks. Welcome to everyone. Just to make sure you have the link to the slides, I'm going to put them in the chat box. And today we're going to be looking at a task that is ready to implement in the primary grades, but it is accessible all the way up through even our middle grades. And the math routine we're doing is called Between Two Numbers. That's one of Fawn Wynn's math routines. And also our rich task is measuring a puddle. So it's all about measurement today. On side 3 is where you can go to get additional templates. So if you're looking for something to use with your class, there are many templates available. And also all of the previous recordings and materials and resources from past MATHurdays are available on my website as well. Join me on slide 4 or 5, either one you like, and tell us a little bit about a success or celebration that's happening in your world. It can be related to teaching in math, or it can just be related to your lives, but we love to hear a little bit about our community. And I'll share mine because I'm so excited. I painted some pottery while I was on vacation in Florida, and it came back. If you live in the Northern Virginia area, I highly recommend the link on slide 4 to paint pottery. You do it at home, you send it back in, they fire it for you, and then you get this beautiful ceramic keepsake. So, Stacy, tell us about the movies.
Oh, it was fantastic. I mean, it was nice to get out, and it was just fun to go see a movie again, sitting there eating popcorn. And by the way, if you like to jump, A Quiet Place is fantastic. Okay, it's not gory, but it will make you jump multiple times.
Wow, I can't imagine being back at the movies. This is actually pre-pandemic. I'm not really like that much of a movie person. I'd rather like kind of sit back, watch some Netflix, pause it when I need to. But I like taking my kids to the little dollar theater and just, relaxing as they take in a movie. So cool. And if you are new to us, join us down either slide 4 or 5. You can pick. And make sure you click this link because that'll let you actually write on the slides. You can insert your own text box and write in here about things that are happening in your lives so you can join us in our community. Lily, where are you coming from and what's the temperature like and why are you excited that the air conditioning is back?
Hi, Teresa. So I'm right near your neighborhood, well, in the Fairfax, Virginia, but somehow my air conditioning broke during the last week of school. So it had to be the parts needed to be ordered and it was delayed. And I was told that was due to the COVID effect. All the shipment has been delayed. So we were without air conditioning. So my home country is Japan, and it's notorious for sticky summer. So if I can't go to Japan, then I have to bring Japan to me. So that's what happened to me. So we survived.
And Lily, where in Japan? Because one thing that surprised me, I visited Japan several years ago. I hadn't realized how long it is. So when we went to Tokyo and then we went down to Sasebo, it was like Virginia to Florida, like temperature wise.
Okay, so you passed my hometown of Nagoya. That's about 2 hours southwest of Tokyo, and that's before you get to Kyoto. So that's my hometown. So I grew up, I was born and raised, and I left Japan when I graduated from my university, then came to Mason to study.
Wow, how cool.
Mm-hmm.
It's
Yes.
beautiful country. Well, I'm glad you have your air conditioning back, and thanks for sharing that with us.
Thank you. Good to be back.
Gail, so what types of things are you reading?
A variety. Fantasy and The Woman Who Smashed Codes is narrative biography about a woman who worked and during World War One and World War Two for the U.S. So fiction. I'm reading a lot of different things. It's really good to have a chance to.
I just put that on my reading list. Thank you. And Lara, what's your favorite book so far?
Buenos dias, good morning. So right now with one of my students, she's on Goodreads. I don't know if you guys know, that's like a platform, like a social media app. So I'm on Goodreads and she's on Goodreads too, and we're working our way through the Percy Jackson series.
Oh, I just got an audiobook of Percy Jackson, one from my library too. I can't remember which series set it is, but oh no, it's just a different series from, is it Rick Riordan?
Rick Riordan.
Yeah.
Rick Riordan, yeah. He writes a lot of books. So it's fun. Like, I've read the series before, but it's nice to go through it with one of my kids and like her excitement about it and just talking about characters with her.
Oh, how lovely. They are so lucky to have you. Well, everyone, welcome. I'm so glad you're here. You can continue to write and add things to our successes and celebrations. It's nice just to be able to connect with other people, even from far away. And if you want to join me down on slide 6, this routine is one that is fairly new to me, but I'm so excited about. It's called Between Two Numbers. There's a link for you there, and on Fawn Wynn's Twitter handle if you want to follow her. And so the website already has tons of images, tons of numbers for you. That means less work for you and more thinking that the kids are going to be doing. And I'm going to do my best at taking what Fawn has and doing it in a way that works for online. So let's give it a whirl. Join me on slide 7. This is just some really interesting numbers, some facts. And while I know in the primary grades, fractions aren't necessarily as robust as they are in elementary, I know that kids really work with that idea of 1/2 and seeing where a half is. And so I thought it was neat to put in some other information about ants. And slide 8 is where we're actually going to begin our routine. And these are real numbers. These aren't none of those made-up mathy numbers that you sometimes get in word problems and you're like, who buys 47 watermelons? So these are real numbers. The average first grader's foot measures 7.5 inches long. A carpenter ant measures something inches long. And the question here is, how many ants in a line are the same length as a first grader's foot? Now, if we use the numbers between two numbers routine, we wouldn't necessarily have this little cloud, but because I'm working with adults, I wanted to kind of spice it up a little bit. So think about that. And slide 9 is where you're going to post your estimate. Just find any little colored box that you like. It's going to be yours. If we line those little ants up, how many do you think it would be to be a first grader's foot? And as a little classroom management tip, my students are usually assigned a color so they know exactly where they type. There's no confusion, and every time they see that color, that's right where they type. So let's start off first with this one in purple. Somebody wrote 14. If that was you, I'm interested in what went on in your brain to come up with the number 14.
Hi, Teresa. It's Raha. So I kind of did what my kids do all the time. They kind of estimate using their eyes or their hands, and they'll be like, oh, how many of them would kind of line up next to each other? And then I kind of just counted by twos. And I got about 12, and I was like, that doesn't sound right. That's like exactly a foot. So then I was like, okay, the closest even number in my brain is 14. And so I went with 14.
Tell me about the even number part.
So I like to use even numbers when I'm kind of estimating something. Just makes my heart happy. So when I estimated it was about 12, I went to the next even, which was 14.
Neat.
And I also didn't want to deal with like with fractions, when you do odd numbers, there's a fraction involved, so I just wanted to round it to the whole number.
Ah, neat way of using even. Speaking of odd number, let's hear from someone who did an odd. This light blue one has 15. If that was you, would you turn on your mic and just tell us, like, why did you pick 15? What was your brain doing?
Looking at 7.5, I thought maybe put the half aside. So then visually, looking at how many halves that I can count all the way to 7, and then that would be 14. Then I wanted to do something about 1/2, and then I just went one more, if that makes sense.
It really does. So we have two different ways on here. We have Raha's way in purple, where she kind of lined some things up and used imagery. We have Lily's way of kind of putting that half aside. What I'm going to ask is, if your way was very similar to either Raha's or Lily's, that you move your little text box underneath whosever's, that yours was like, yeah, mine was just like that. And if it was different, keep it right where it is. So now I've got purposeful listening, intention to decide, which one it's similar to. And we have a couple other people who are identifying that theirs is maybe different, that they didn't do what the previous ones had said. So if you were 17, would you tell us what you did? Oh, I think maybe 17 might be moving theirs. If you did something different, go ahead and let us know. And if you were the 15 in orange, would you tell us what you did?
Yeah, hi Teresa. This is Soumya. Yeah, I did it actually. Now that I'm listening to other people, mine seems so tame. I just remembered that you showed us that carpenter ant was 1/2 inch. And so when it was 7.5 inches long, I said it's 15 carpenter ants. That's it.
So what did your brain do to go from 7.5 to 15?
I don't even know. I'm not sure I know. What did it do? It's half. So I mean, when I see the half and there's 7.5, I know it has to be a double. So then I just go to 15. That's it. I don't think I have anything more helpful than that.
So you did doubling 7, and that. Oh, and 7.5. So you didn't break it apart. You just said double 7.5 is 15. Perfect.
Yeah.
Lovely. And I did put that up there. So let's go ahead and take out this little bubble. You may have seen it from before. A carpenter ant indeed is 1/2 inch long. And another strategy that sometimes students might do is on slide 10, because things are so interactive, they might have actually lined them up. And here we've got them lined up on slide 10 if you wanted to kind of explore that one there. Yeah, so that's our routine. And I've posted the directions for what I did on slide 11 if you want to implement this again and remember what I had done. First, you visualize it. You show the two images, and then you numerize it. You find a way to put numbers with it. Students will estimate it, and then we calculate together what are different ways that we could find that relationship between two things. And so this will bring us not only in the primary grades, where we are counting how many non-standard units fill up an object, but it'll bring us into the middle school grades, where we're really talking about proportional reasoning. So this is something that's important in primary, elementary, and middle. All right, let's jump into our rich task. On slide 12 is the reason why I do this. This is so important. Those of you who visit regularly for MATHurdays probably have this memorized by now. But we do rich tasks because they are so purposeful. There's so many ways to connect mathematical representations, math discourse, conceptual understanding. And in our discussions, it'll all be based on student thinking, your thinking that you provide. Before we begin, on slide 13 is our problem-solving oath. I'm going to read it out loud. If this is an oath that you would like to take, you're going to put your name in the chat box saying that I pledge this today. I, insert your name, Teresa, promise to try my best. I will make sense of patterns and numbers. I will use manipulatives and drawings. I will make mistakes. I will ask questions. I will listen to other ideas. I will stay engaged by always trying to find another solution or representation. I am a problem solver. I make the world a better place. Awesome. All right, folks. Let's go ahead and begin. Before I launch a task with our primaries, I always try to give them one more kind of launch into it to get ready. So on slide 14, these are movable stars. You're going to look at this picture of a puddle and think, how big is it? And drag one of those stars to one of those 4 quadrants. Is it as big as a house? As big as an ant? As big as a kid? Or as big as a dog? Go ahead and grab that star and move it to one of those 4 quadrants. And if you can't decide between 2, you can put 2 stars. What I'm doing right now is getting students to be interested in relative measurement, comparing one thing to another, because that is part of our task. So we're going to measure a puddle. And slide 15 is group 1 slide. The other groups are below. The directions, by the way, are clickable and go to Google Translate, where it will actually read it out to you in English.
Directions. How big is this?
Or in your chosen language. But what you're going to do is measure the puddle in any way you like. When you find that you've finished, you're going to duplicate a slide. You're going to find another way of measuring the puddle, and another way, and another way, and another way, and another way. There's some tools to the left that you can choose to use. They're semi-transparent, so they might be nice to measure it. And when you meet up with your partners in just a minute here, make sure you say hi. Ask them how they are, where they teach, and so on. And then go ahead and drag some things around and measure that puddle as many ways as you can. I'm going to go ahead and create those breakout rooms now. All right, your rooms are open. There are people waiting to engage in math with you. You might need to minimize your browser window to see the invite from Zoom. But if you can still hear me, go ahead and minimize your browser. Zoom is usually behind it, and that's where you've got the invite for your group. Sheila, let me know if you need any support with that. Oh, perfect. If you're watching the recording of this, I typically spend just about a minute on my own in the main room. It gives me a chance to kind of put myself together as a teacher, get ready to start looking for things. I've already anticipated several ways that people are going to solve this. I think that they're going to look at it as length, as width, perimeter, area, non-standard units, and standard units. I always sometimes find somebody who notices the little squares that are the reflection of that building in the puddle, and will use that for area and more. And so I'm just interested in seeing the different ways that they will come up with those. So now I'm going to go in the different rooms.
The clear part in the middle, I'm assuming that's the puddle.
Okay.
Um,
Okay, so
What I like to do is if you right click on the image, there's a part that says rotate, and then you can rotate it clockwise, anti-clockwise, flip horizontally or vertically. Yeah. That helps.
So you're going to fill it in with the little yellow cubes?
Yes. As much as I can.
Hi there, group.
Hello.
So when we're filling something in with the yellow cubes, what is it that we're measuring?
I was
Very-
thinking of measuring how wide it is from one end to the other.
Cool.
I just have a hard time with the picture, so I'm gathering the reflective part is the puddle. And is that other stuff supposed to be dirt or gravel?
Yeah, so we sometimes will talk about the picture first also, because this one's neat. There is this kind of dirty, gravelly stuff there, but there's also a reflection of a building. And those little squares in the building, some people pick up on and use that as a way that they're going to measure this thing also. So it's a very interesting picture.
Okay, I think I want to start.
According to the football that you are using, then you
I can move that.
No,
I
I
can
just
move-
want this. I just want to make sure that I understand what is the puddle.
So exactly. So let's start with the definition of the puddle. And so
Mhm.
let me move my footballs away. I'm just going to line up my football vertically and I'll move it out.
You can save it. You don't need to delete it. Yeah.
Yeah.
Hi, group. I just wanted to pop in and let you know that the way that you're thinking of approaching this problem is a fantastic way of just stepping back and saying, okay, but where is the puddle in this? Because there is some like dirty, gravelly stuff. There's like a bright part of the puddle, and then there's like this building that's reflecting into it. So there's a lot going on there. Definitely discuss what you're going to define as the puddle, and then, yeah, start measuring.
Thank you.
So do you want to use this scribble tool to define the puddle?
Yeah. At first, I thought my blue line there is the.
I thought I did. Maybe it's not. Oh, I know what it is. It's not changing. I'm trying to go from the lower right to upper left so
Oh,
that the
I see.
proportion, stays the same. but it's
Mhm.
not letting me make it any smaller.
Maybe shrink down the font size of the table because it thinks
Oh,
that like
that's a great idea. It
I
sets
that sometimes
14.
happens.
Let me try with maybe 10 and see what happens. It's even,
Now it is shrinking down.
yeah. All right, maybe I will even, oh, sorry.
Oh no,
Hi,
don't
group.
apologize. No,
This
no
is
worries.
such a great way of thinking about it. Once you have your table that you're working on putting on top of there, what do you plan to do with it?
So we started by debating like where the parameters like of the puddle actually like we had a hard time deciding where the puzzle like what the boundaries of the puddle were. So we decided we were just gonna lay the grid over and then move from there.
And what once you get the grid there, are you going to be counting things? What's the grid going to do in order to help you measure?
So we're thinking maybe from, figuring the square units that would be on top of that puddle. And we had a hard time deciding or figuring out what constitute a puddle. And we were trying to see the left edge, the right edge, the bottom edge, we're trying to figure out. So then having that transparent grid, we're trying to make it as close to the size of the unit cube square that you gave us, but maybe the font is too big, or I'm having a hard time
Shrinking down.
shrinking it down. Although it's getting closer, but
Because we
then-
wanted to make it the size of the unit cube.
Ah,
unless we can come up with our own version of one unit.
totally. You
So
absolutely
then
can.
that way, then we're ready to go. Then we expand the rows and the columns to cover the entire area, if that's okay.
Very cool. Keep it going.
Okay.
Change the font size to 3, Lil.
Hi there, group.
Hi.
I see we have one, it looks like one person's working on lining up a bunch of yellow squares. Someone else is putting rulers all around it. And other ones are quarterback. So what are some of the different units of measurement you're thinking about?
So I'm working on the yellow squares and I'm using yellow squares to measure the surface area of the paddle and measuring in yellow squares.
I find it interesting that you said the word surface area. And in at least in Virginia, I know around 3rd grade we start talking about area as being a unit. But this idea of surface area and how that's different from, how deep it is, which if I'm thinking of like really young kids, the how deep it is, that's where the fun is, right? Like I'm going to splash into this thing. But oftentimes when we're thinking about maybe paving a new surface or fixing a pothole or something else, it's the surface area that's really important to us.
And I think that's what I was thinking about when I had to choose between the boy and the dog and the size of the paddle. I was thinking about depth as well.
Very cool. How about the rulers? On slide 19, we've got rulers in all different directions. What are those measuring?
Yeah, I'm trying. Can you hear me?
Yeah.
One. Yeah, I'm trying to see if I can break it up into different parts that are geometrically easy to measure, perhaps.
Oh, I see. So you've got like some triangles, a quadrilateral. Neat.
Yes. And then I will have to account for the bits that I have not covered.
Oh, I see. Very cool. And how about the footballs? What type of measurement are you determining?
I'm also trying to calculate the area, but instead of the squares, I'm trying to use this ball.
Cool. And what grade do you teach?
I'm actually teaching grade 4.
Okay. So, one thing that I love bringing up with kids is like, why, when we do area, do we call it square units? And are there other units we could use? And it turns out that you can measure area in this discombobulated way using triangular units or hexagonal units, but only things that tessellate, because we don't want gaps. And what I love about this is how you've lined up the footballs in a very purposeful way. But I know for me, my first thought is like, well, how do we account for the gaps? Is that like a half a football? And so we can get into some great discussions about why we call it square units.
Okay, that's a good point.
I think you should keep going with it the way it is, because I would love to have that conversation with the whole group is what do we do about the gaps, and bring it back to the square unit idea.
Okay.
Very cool.
So we had, at least I had, and I think one other person, maybe Gail, we were wondering what it was that was measurable here when we first saw the picture.
And I was wondering if you were maybe working also on the distance around the puddle with your rulers, because you could also use it for that.
So, and Gail, tell me again what you teach. Is it pre-service teachers?
Yes.
And what grades?
This is their beginning content classes.
Is it for elementary or secondary pre-service?
Elementary through 8th grade.
Oh, okay.
Somewhere.
And Salma, what grade levels do you teach?
I work with teachers all the way from grade 1 to grade 8.
Oh, okay, perfect. Yeah, so this idea of perimeter and going around is definitely something that they use. And I always find different mathematical problems to be interesting. And one of them is, depending on how zoomed in you are on an image, the perimeter starts to kind of look a little different as you go around every little jagged corner. And it's a great question I like to bring up with my secondary folks. So, that 7th, 8th grade might be interested. If we, bring it up into 12th grade, we can get into some calculus there by keep zooming in and keep measuring around every little nook and cranny. And eventually we get this like infinite perimeter. So.
Right.
Cool. All right, I'm going to check in with some other groups. Y'all keep it going. This is great.
Yeah. Thanks.
How did I make the circle?
Yeah.
Just using the shapes next to the scribble tool.
Nice.
So I'm going to group that.
That will be a lot, easier to estimate the area than the squares.
So if I have one circle there, and then I try to cover up the picture with as many circles, it's not the best because I have a lot of gaps in the middle. But it's faster than so yeah, I don't know. Now that I'm looking at it, I feel like I might not, because there's so many gaps. So
we can combine those gaps and estimate, how many squares.
And how do we get an estimate of it, this way, the circle strategy?
Oh.
You think it might work?
I feel it would work.
Great.
Well, then I'll keep going, but I'm not so confident. I feel like the little squares would have given me a better estimate, but it's too much work.
That is true. Let me see. I'm going to. Just trying to see, the space for 3 square units
Mm-hmm.
and see whether maybe it will help us.
Yeah. Yeah, I like that. So we can fill in the different spaces with the squares.
Yeah, we could do that.
And then if you know how many squares go into one circle, then you multiply that by 7, and then the others are just filled in.
Yeah.
I like that idea.
And the area of the square, your diameter is 10 centimeter, right?
Correct.
Okay. So then we can calculate the area of the circle, pi r square. 1, 2, 3, 4, 5, 6, 7. We have 7 circles. I am. Oh, you're going there.
So yeah, I think we have a fairly good estimate, or method. Huh?
Yeah, we are just estimating right now.
So we have something for area, but do we have any other measurements we want to look at?
Oh, all around?
Say that again?
Are we supposed to, yeah, we measure around the puddle.
Oh, the perimeter.
Yeah.
Yeah. Oh, that foot part, that one would have been a good one to measure perimeter.
Oh, where's our foot? Right here?
Yeah, it's on I think I deleted it on 16, but it's on 15.
Nice.
But I feel also those those balls would be a better way also since it's longer.
It's longer. Yeah. Well, let me see if I can get the foot, because it's this whole rotating and making it align with the line.
The bottom all the way to the top, and then I was going to do the feet diagonally from the top left to the widest portion of the part that we can see that I guess the graph is covering.
Kind of like this?
Yes.
So I'm going to keep going so I can cover more with the feet. Okay, so you said widest. Should I leave the 2 feet here or just...
Yeah, no, leave them there, yeah. Okay, so we're about 6 feet high.
Yes.
Welcome back, everyone, to the main room. I do hope you enjoyed the task. I specifically picked this one because it's accessible and ready to implement with primary kids, so that K2 band. But I saw that so many of you, took it to all sorts of different levels. And so what I did is I looked at the student work I had here, and I'm going to talk about area and the progression of area, because y'all provided just some beautiful pieces for that. I'm going to use the formula on slide 24 during this discussion, where I have been monitoring in and out of your groups, listening for strategies, selecting and sequencing just the ones I want to talk about, and now we're going to connect them here. So if you would join me on slide 25, I want to be completely transparent and let you know that some groups worked even more on these. But one of the beauties of working online is I can copy it in its rough draft phase, or if I saw something earlier and you added more on it, I could take it off on the copy so that it can help us answer the specific question that I'm going to ask you. So in group one, I was wondering if you could start us off by just telling us what was the important question you asked, and what does this blue line represent?
I could start us off. So we were trying to figure out how do you measure length or depth, or how do you measure how deep it is and things like that. And then somebody, I think it was Remy, who said, well, I can't tell where the puddle is. And so we thought the first step is maybe to define where the puddle is, so we could even see where we should measure length or width. And so we used the scribble tool and did this. Obviously, I've missed out quite a few because we had a bunch of other props that we had put on the slide, and so which hid these little potholes at the bottom. But so that's kind of what we did to define it. And then we started to see where's the longest part and the shortest part, and what do we want to measure and stuff.
That definition that your group talked about, and you talked about it for a little while, really defining it, is the most important part here, is defining what it is we're going to measure. And that's something that's needed in, first grade when they're measuring how tall something is, all the way through. Guess what? You just made a calculus problem here. Calculus is all about, figuring out the area under a curve, or in this case, this curvy area. So we could, take this problem right up there, but we're going to stay in the primary grades. And on slide 26, this group had a similar discussion, but they started to define the puddle differently. So group 2, I'm going to have you explain in more detail the next part that you did, but tell us where your thinking was at around this stage in your work.
Okay, I can add something to it. I just remembered that the best way to measure or figure out the boundary of the puddle, which we were really trying hard to define, would be to put a grid on top of it. So thanks to you, Teresa, I learned how to insert a transparent table over a picture from previous lessons. So then we decided to cover the entire area so that we could highlight in the area where we considered a puddle. And that was just at this stage, that conversation that we're having at this stage.
And then tell us how you determined which one got a yellow coloring. And I can see a tiny little bit of puddle here. How come these ones weren't colored yellow? What was your decision making for what got a yellow square?
Lauren and Colette can join me if you want to define, but I think at this stage we're trying to cover the major areas, and because we were having a hard time adjusting the size of each square unit to the size of your square unit, so we spent a lot of time trying to shrink it, and then we couldn't. So then Laura had a brilliant idea to expand it so that our square unit is 4 times of your 1 square unit. So that's where our conversation was going.
Cool. And earlier in our lesson, we brought up that number 1/2. And so if you had chosen, I know sometimes people will say if it's more than half watery or less than half watery, so we could bring up that language again there. Lovely. On slide 27, group 3 did something similar, but theirs might be a bit more accurate. So group 3, what did you do that was similar, and why does the way that you did it might make it more accurate?
So I took the yellow square that you gave us and iterated it, kept copying it and groups of copies and trying to fit it into the boundaries of the puddle. And because of the size of it being smaller and having them separate, I could fill in odd shapes probably better than the slide before this one.
So we can get into those little nooks and crannies a little bit easier. Another thing to note is that on slide 26, they redefined what they called a yellow square. On slide 27, they went with the yellow square that was there, so we can really get into the importance of using the name of the measurement. But let's continue with this idea of accuracy and area. On slide 28, this group started to get a little more accurate. So group 2, again, kind of tell us where you went next in terms of accuracy.
So we had started to first we just went for the largest chunks, but then we noticed that there were little pieces that we hadn't covered of the puddle. And because our unit was 4 times as large as the unit square, we knew that we could break up our unit. And so you can see where Colette and Lily started to pull little fourths of our unit. And we knew that as long as we had 4 of them, it could equal 1 of our large unit squares.
And so I can see in our previous question, how did you decide if it gets it? If I move this, I can see a little bit of puddle under it. So you've been able to get this more accurate and capture more of the puddle. And as we continue into accuracy, we're now starting to bring it up into the middle school grade levels. But on slide 29, group 3 had a different way of thinking about measuring area. And group 3, can you tell us, how did you use these rulers and what was your thinking?
Yeah, so one of us went with a little yellow square, so I thought I would try something that was not that. And this idea of breaking this puddle up into geometric shapes, that's where I started. And so then I could not do all of them as right triangles, and I didn't want to get into non-right triangles. That's why I stuck some, a trapezoid there and some other shapes. But yeah, that's where it came from, and it is, I can see it's extremely, the precision is low here. But yeah, that was the thinking.
It's a nice transition into the middle grades where they're learning area of triangles, trapezoids, squares, rectangles, and more. And so they can apply that thinking as they decompose this shape to get a little bit more accuracy. And then if we can continue our journey on accuracy with area, let's look at slide 30. And what's interesting about slide 30, I'm going to let this person kind of take over, is when we use footballs, will this give us an accurate measurement? And so let's see, who was it that did this one? Can you talk to us a little bit about the conversation about accuracy?
So this one, the problem with the football is that it's not covering the exact, there are spaces which is not covered by the football. So that's why this one is the less accurate one of using or of measuring the area.
So these little gaps, we might even take the footballs. And I see other people working on it. This is not their original work. This is a copy of it. So you can feel free to tinker and play with it if you want to. We could do things like that to line them up and maybe get a little bit, but you know, they are kind of overlapping. So why don't we use footballs as an area measurement tool? You may have noticed when we come up with area, we're told by our teachers to put square units. We always put something squared. And it turns out that we could measure area by anything that tessellates, square being the easiest, but we can do triangular area. We've done it in other MATHurdays. You can even do hexagonal, but it gets a little bit more confusing. If we just use squares, they tessellate, so there's no gaps, no overlaps, and we can really measure things. But on slide 31, this group decided to use multiple things to measure. So group 1, go ahead and take it away again with us. What's going on with the circles and squares?
Okay, I'll go again. We got lazy. We didn't want to do the yellow squares, even though we realized that that was the most accurate. And so we thought, okay, if we find a shape that we could kind of transpose on top, and then we should have taken a little bit more time in either making it a square or a rectangle. And whoops, I don't know. Can you hear me?
Yes, if I think someone just hit delete, but I put it back there. Go ahead.
Okay, so yeah, we thought if we could find a shape that we could transpose on top, and then fill in the gaps with the unit squares, then we might get a little bit more accurate without having to go grid by grid by grid. But that grid idea, I don't know how they did it, but that's really what we'd like to have done. Like find a grid and then kind of replicate it. So kind of getting there, but well, we just chose a different shape, I suppose. And but talking about accuracy, we went back to, in grade 1, we might not be doing area, we might be doing distance or length. And so we went back and did the, there was a little foot image. And so we walked the foot all around the irregular shape that we drew to see, and why we use the foot instead of the larger ruler or a football was because the curves would be more accurate with the foot. So we kind of talked about what would be accurate, but in this image, it's all over the place.
I love that it's all over the place. It really gives us an opportunity to talk about units. So bringing this up into middle school, if I was going to have these circle units and these square units, I need to have a common conversion for them to be able to say how big the thing is. So folks, we had talked a lot about area, and that was just because that's what you all provided me. I couldn't pass this opportunity up to look at the perimeter going around with the blue, to the squares, to the progression of accuracy. But Lydia brings up a great point. We should have been talking about length. And on slide 32, I'd love for you all to stretch this from K-12. If you could have measured it with the tools, tell us what you could have measured in green. If you could measure it, but you didn't have the tools, for example, temperature is measurable. I did not have the tools to do this on a screen. You can put that in red. Let's see what other measurable things are out there. Ooh, density of the water. We could measure angles. We could measure perimeter. So I'm really leaning on our primary teachers. What are all the things that students have to measure? There's big measurement units. And as you're filling those in, I'm going to kind of go back and do a little gallery walk of our slides. On slide 15 here, I'm showing the little feet going around the perimeter. Which ones didn't we do yet? We have a wet kitty on slide 23, and this group on group 4 really did a fabulous job of looking at length, width. We even have a triangle where you could get into hypotenuse and stuff there. But theirs are all linear measurements. And the beauty of this question is kids will come up with even more. Some of them will say the height of the splash you could make in it, which then we find out is determined by volume, depth, and more. Weight and mass. So measurement is a standard that's used across K-12. We really do discuss it early in kindergarten. It's important to know that we can't measure how long the puddle has been here. So there's time, there's weight, there's temperature, there's capacity, there's density, there's height, length, width, perimeter, area, angles, and more. And these stretch from K all the way up through Calc. So I hope that this is something that you can use in your class. And I wanted to close out today because, if you can believe it, we're at the top of the hour. On slide 34, I have tried to give us a little bit more of a heads up of some of the MATHurdays coming up. Today was primary based on measurement, meaning you could take this and immediately put it into a primary class. You might have to tweak it for others, but I promise to make all of our lessons accessible to you no matter what grade level or math background you have. But those are the ones coming up for the next 5 weeks. And if you have any questions or you want to learn how someone did that table or questions from me, feel free to let me know. I'm going to open it up. And if you want to see other things, add it to our virtual parking lot. So thanks for coming. And if you have questions, go ahead and let them loose.
Hi, Teresa.
Hi.
I have one question. I've been hearing about some tool called Pear Deck. And there were some teachers telling me that this was really lovely and they checked it out. I have no experience of it. Are you familiar with it? How does it compare with this or whatever?
I have a little bit of experience with it. There's some fabulous thing for Pear Deck. We have some people here who are pros in Pear Deck, so I'm going to have them take over the conversation of this.
Great.
One of the major differences that I've seen is that I like the interactive slides because they're collaborative. So when you move the football, everybody else can see that football being moved. And so we're all in the same, like you see it, I see it, we see it together. Pear Deck, though, provides great opportunities for quick check-ins, individual assessments, and more. I know we got some Pear Deck people in here, so I'm going to let you take it over, and then I'm going to get ready to demo how to do the grid on the slide, unless our person who did the grid wants to show us how to do it.
Excuse me, sorry.
Soumya, I can relay some message about the Pear Deck. I teach 3rd and 4th grade, and I had a student who had the difficulty in reading, and also special ed student. And Pear Deck allowed students to click a button and listen to all the directions in the audio. So that is an amazing tool. So I have to, so that it gives them an equal playing field. And also, if you use the feature, they can actually draw, color, and then also type text all on their slides. And it is just a wonderful, friendly tool for anyone who needs a little accommodations as well.
Okay, thank you. Students don't delete slides. Okay.
Yeah, this one, because it's the first year that we have like virtual classes and the kids are not yet used to the slides and the Jamboard. So some of them, when they are panicking, they want to delete some parts of their work and they ended up deleting the slides.
Okay.
So that one, when we're using Pear Deck, the students, they will just delete what's on their own slide.
Right.
So this one, so I think, but the good thing with the Google Slides is there's like the interactivity, which is not that much seen on Pear Deck because they'll only be working on their own slides.
Okay, and they cannot see others.
Unless the teacher shows the responses.
I see. Okay. And can the teacher see everybody's work?
Yes. Yes.
And
Great. This is really great. Thank you. Yeah.
the other one that's similar to Pear Deck is Nearpod. If you're looking, some people will definitely have a favorite one over the other. From what I've seen, they have a lot of similarities. The other one was, is there somebody from group 2 that's still on that wants to show us like how you did that grid? What I can do is I can put on a new...
Sure, I'm still on.
All right. If you want to come up to slide 17,
Laura.
that one's blank, and you
Sure.
can. I'm going to stop sharing. I think you should be able to share your screen.
Okay, so let's see. I can. This is my first time attending your session with Zoom, Teresa. I
Oh my
was
gosh.
almost panicking this morning, like, oh my gosh. Okay, how do I share my screen? My
Do
goodness.
you see at the very bottom, you have things like your
Yes.
microphone, your video.
Oh my goodness.
There's a
It's screaming
share
at me in
screen.
green.
Mhm. Yeah,
Yes.
that's it.
And then I see so many, obviously, because I have to go to the one, it says screen number 2.
If you have two
Oh, wow,
screens
it
up,
gives
yep,
me-
that'll be the one.
Yeah. So I have to go screen 2, I bet. All right, so am I on?
We can see it.
Okay, so did you say 17?
Yeah, that one's blank if you want to go ahead and do
Okay,
that.
so first you have to make sure that you're on the slide so I can see that the 17 is highlighted there. So then I'm going to go to Insert and Table. And when we are working on this, we try to do 10 times 10 just to see how it feels, and then release it, and then it fills the screen with the 10 by 10. And then we were sad that it wasn't a square unit for each of them, so we wanted to bring it to the top where we thought that the puddle started, and then trying to keep the proportion, we're trying to shrink it to the size as close to as possible to the square unit. And that's when we run into a problem that we could not make it smaller. And I think Colette or Laura suggested that we change the size of the font. Laura, did we say that we shrank it to like 3? Is
Yeah,
that
we did. And the
Yeah.
table is automatically transparent
Yeah.
unless you change the background of the table. So that's why
Right.
it shows up as transparent.
Yeah. So then we wanted to fit that one unit cube, and Laura had a brilliant idea. If you can't shrink it, then enlarge it, so that we thought that number 4 would be a great, easier and flexible fraction, so that we could do, let's say 52 square units, and then we can, 1/2 or 2/4 or 1/4. So then we just adjusted how many, the 4 of the original square unit will fit in there. And then for highlighting, we highlighted and then went to fill in the color. And then first we chose the yellow, and then it fills too much, so that we highlighted it again, and then went to custom. And that allows us to make it transparent. And that's how we got the transparent color. So then you can see the original picture, but it's highlighted at the same time. And thank you, Teresa, for teaching us during the
Thank
session.
you. Oh, that's great.
What a beautiful demo. I did get that on our recording. So if you need to see it again, when I post the recordings there, you'll be able to watch
Lovely.
Lily's beautiful demonstration of that. And way to go.
Thank you.
So I don't see any other questions in the virtual parking lot. If you have them, feel free to put them up now. Say them out loud. Otherwise, if you don't have any more, hope to see you next week. We're going to investigate some middle school proportions, but I promise that I make it accessible to everyone. No matter what your math background is, you are a math person who can do those problems.
I have one question about how we would use these activities, Teresa. The early routines that we do right at the beginning, that I understand. Though you sort of open the class up with that, and it's 5 to 7 minutes. That's these deeper, richer activities. How frequently would you think they would be happening in a class? Like, do you see every session like this? I'm not sure I get that sort of picture.
Yeah, so I have experience working in, I think about 10 different schools as a math coach. So I can tell you that every teacher is different, every administration is different. Here's some of the ways that I've done it as a math coach is I'll work with a teacher and I'll say, in a perfect world, how often would you like to do rich tasks? That kind of becomes our goal of maybe where we would want to go. But usually it is at least once a unit. So I'll start off the unit by saying, let's do a rich task at the beginning of the unit. We'll have some discussion, but we'll tell the students we're not solving anything yet. And then we leave it out in limbo for the entire unit. And at the end of the unit, we come back to it and we say, all right, let's put some numbers up for a solution or an answer. And then all unit long, we get to keep referencing the puddle. Oh yeah, now we've done measurement. Great, we've done that. So it becomes like an integral part of the unit. And that's the way that I ease rich tasks in with teachers who may not have ever done them before or not sure how to bring them in. Once they have the hang of that, I start to say, like, why don't we do a full rich task at the beginning, a full rich task at the end? When they get the hang of that, then we pop one in the middle. And so we kind of use those as little benchmarks to see what students know. We use them as pre-assessments so that we don't have to reteach anything that we realize that, gosh, the majority of our class knows. Maybe these couple of kids here, we pull in a small group and, we have a mini lesson. And then eventually, so my perfect classroom, if I'm looking at like a 5-day week, I would do rich task probably 3 of those days. The other 2, I would do math workshop where they're in small groups. I'm reteaching or introducing stuff to small groups of students who I can tell, from these need it, or extending ideas, but those groups aren't the same groups every single week. They are very specific to like that little mini lesson that we're doing. And that's the way I enjoy teaching. I find that I can reach all my standards more purposefully that way. But again, each teacher and each administration is different.
Sure. Thank you. That's very helpful. Yeah.
Hey, Teresa, I was just wondering if you had a list of those primary resources.
Oh, I started getting them. I didn't finish it. You're right.
That's absolutely fine.
One of the ones...
If there's one thing that you want to recommend so that I could just look that up for this week.
So I think the 2 that I love just starting with, Marilyn Burns's books about teaching mathematics is the staple for primary for me. I also like pretty much everything that Kathy Richardson has in terms of primary. And then in terms of reproducible worksheets that aren't really worksheetish, I like the Groundwork series a lot. They are all about higher order thinking, but they are something that you can reproduce. It is worksheet-like, so you feel like you can kind of have that little breather as a teacher. But Lydia, I want to get that list growing. Let me think about... I want to do a better job of that. I know you always seem to come for MATHurdays, so keep asking me every week. I'm going to make a point to add to that.
No, but this is a really good start for me to go look through because I've not done these taught these grades before, so thank you.
About Teaching Mathematics is a beautiful book. It transformed the way I teach math. But also, Marilyn Burns has, in the Math Solutions, she has picture books that goes along with the grades. So you can read a picture book to the kids and then immediately go into your math lesson.
Wow.
And that's really powerful. So let me see if I can find that for you all while we're on. But otherwise, I'll add it to my list. They even have like little sets of these picture books.
When so we use Fred books with my kids.
Okay.
And I'm trying to see the book A and book B for grade 1 and grade 2, but then it seems I couldn't figure out how to make it into a lesson that fit, the curriculum kind of thing. So I'm definitely going to look at the storybooks that Marilyn Burns has.
Yeah, I think the quintessential book when I think about the Marilyn Burns series is The Greedy Triangle. I'm not sure if you're familiar with that book. If not, go to YouTube and get the read aloud of The Greedy Triangle. It really showcases like all that she does in terms of getting kids to think conceptually about something. But let me look in my resources. I know I've got the picture books that go along with stuff. She does a great job with that. And other ones that I have at my fingertips. So Jennifer Lemp does Math Workshop. That is a great read. It's not going to give you a single lesson to go and implement right away, but if you're looking for like, how do I get my kids in these different groups, like 5 different groups, all 5 are doing different things, they're responsible, they're independent. I can do a small group and do reteaching over here because my students are independent. She's got a great book on that. Yeah, let me keep thinking of those. There's the 5. The 5 Practices Elementary is another one. Yeah, so ask me again next week. I'll do my best to get a better list for you.
It's going to take me a while to get through this list, so yeah.
I usually jump
Thanks
on this.
again.
I'm like, oh, there's so many different things. And then when I have to come up with it kind of on the spot, I'm like, I'm literally turning around and looking on my bookshelf for the things that I have that are the books that are really like matted and torn a little bit and sticky noted. And yeah.
Well, I appreciate it. Thank you so much.
Any others?
Thank you, Trish. That was lovely.
Sure.
I'll be back next week.
Awesome.
Thank you. Have a good day.
Bye, everybody. Bye, people.
Bye-bye.
Yeah.
Thank you.
Bye-bye.